What's up, everyone? My name is Neha, and this is Alec. I think we're the talk right before lunch, so I'm gonna try to make this quick because I know you all are hungry. I saw there's some tacos outside, so I'm really excited for that. I don't know about you all. Today, Alec and I are excited to talk to you all a little bit about how you can manage your asset security with code signing and how you can implement code signing in your day-to-day life. And so before we get started with today's session, we're going to quickly introduce ourselves and then jump into the wild, wild west of code signing.
Cool. Hi, everyone. My name is Alec. I am a recent graduate of the University of Toronto, and I'm fairly new to the industry as a whole. I've been with NVIDIA for the past 2 years. I actually started as a performance tester on the GPUs, just literally playing games. Eventually found my way over here. Yeah.
Sick. Hey everyone, my name is Neha. I'm also a recent graduate. I graduated from UC Berkeley, just up north, and I studied computer science and business. I've been at NVIDIA for 2 years as well. Alec and I actually joined at the same time on the same team in security. So we have had the amazing opportunity of diving into the world of cybersecurity together. And a lot of what we're going to talk about is actually things that we also discovered as we were doing research together as well. So before we dive in, we wanted to give a big disclaimer that yes, cybersecurity is so broad and it can be really complicated. And so as Alec and I were reflecting on our experiences, we realized what brought us together was really exploring different concepts and finding a way to simplify them in an easy to understand way, so that anyone, regardless of their experience level, can understand cybersecurity. We really resonated with Marco and Jen's initial keynote talking about, hey, the mission of Pacific Hackers being to make cybersecurity more accessible. So hopefully we can make code signing a little bit more accessible to you. So today we're going to talk about what code signing is, why it's important. We're going to talk about how you can code sign, and then also talk about best practices in implementing code signing in your own day-to-day life. So let's go ahead and jump into discussing what code signing is. So at a high level, code signing is this process of showing that your code is authentic, it's verifiable, and it's trustworthy. It's essentially this digital signature that is added to software and applications that verifies that a code has not necessarily been tampered with after it was signed. And so oftentimes when we're developing software solutions, we think about the customers that are using our solutions, how they'll use it, and that experience. And in our case, we're also thinking about how trustworthy is our software and how can our users trust that what they're using is actually, in our case, NVIDIA software, or in your case, whatever software that you put out. And so this notion of establishing trust is really important because it allows your customers to feel confident in your brand, in your software, and also allows you as a developer to have confidence that your software as designed and as intended is reaching your customers. And so with all of these amazing things about code signing, there are 3 categories that we came up with to bucketize these benefits. And so first, code signing confirms who the author is of the software, which is essentially this foundation of establishing trust between the developer and the customer. Second, code signing can demonstrate code integrity, ensuring that the code is delivered to customers and that remains unaltered and in the state that the developer intended. And then finally, code signing leverages this concept of a digital signature, which Alec will go into in just a minute. And this utilizes this concept of cryptographic keys, which is a fundamental part of protecting reputation and also ensuring compliance.
Cool, thanks, Neha. So we know a little bit about code signing. So here's just a little brief, easy to follow example on code signing in action. So at the end of the day, code signing is like putting a unique stamp of approval on that file, or in this case, some binary code that you want to publish out. So this process usually involves using some sort of signing program to generate that digital signature. And in our example, we're going to delve into a specific method called asymmetric encryption. So this type of encryption uses the notion of key pairs, public and private. So they're connected in a special way mathematically, and they're designed that you can't figure out the private key just by knowing the public key. So the idea here is that we got to keep the private key super secret. So when it comes to actually generating a certificate, or when you're generating a certificate for your file, what the signing program will do is it'll calculate that unique fingerprint that I mentioned before. And in the security world, that is called the digest of the file. Then what happens is that the signing program will take the private key and encrypt that digest, thus creating that signature output over there. In many cases, that signature is embedded into that binary code that you're sending out. When that is embedded, that sort of allows any customers that want to verify that code is legitimate by just using the corresponding public key. So why does this all matter? So signatures are seals of authenticity. You can use the corresponding public key to check that the file is indeed genuine, hasn't been tampered with. And this is crucial if you want to run programs or run code that you download straight from the internet.
Great. So now we're going to dive into an example of why code signing is important, and also why building a code signing solution is also important. And so in this first example, we're going to talk about why code signing as a whole is important. And so we have this example scenario where a user navigates to steam.com, which is a seemingly legitimate website where this user wants to download Steam, which is this really cool gaming distribution platform. I hope many are familiar with that here. And so oftentimes in these cases, threat actors can create fake versions of sites and have compromised versions of the software that a user could download. So in this example, the user doesn't necessarily realize that this steam.com website is in fact malicious and not the intended site that they wanted to go on. And they end up downloading this compromised version of the software, which includes some sort of malicious functionality. And so to the user, it could look very legitimate. It could have the right logo, it could have the right user interface, and so forth. But in reality, this compromised software can lead to things like unauthorized access of the device, data theft, and in general, just a lot of bad things. And so this is where code signing comes into play. And so in this case, code signing enables the user to verify the authenticity and the integrity of the software before installation. And so let's say the Steam executable was digitally signed. And so when a user downloads this compromised version of the software, they may see this pop up on the left in red, where the device is unable to verify that digital signature. And therefore, they can't determine the publisher and whether that piece of software is in fact from Steam. However, if a user downloads an actual legitimate piece of software, their device is able to validate that digital signature, and the user can see the publishing information, in this case, the actual steam.com, to see other metadata to verify that, hey, yes, what I downloaded is in fact what I wanted to, it's legitimate, it's coming from this distribution pipeline that I wanted it to come from. And in general, this can really help with mitigating any sort of risks with downloading and installing software.
So let's say you do have code signing in place. I would say like this is probably a great first step, but within your organization, let's say you do have your code signing in place, but you don't have a code signing system. Let's explore why not having a code signing system can be pretty detrimental in itself too. So let's say we have a developer over here who stores their private keys in a server, and the server anybody in the organization can access. Now, when we look at the private key, let's say it's stored also in plain text on the same server. Storing it in plain text facilitates easy misuse, unauthorized access, and allowing people to sign assets that aren't meant to be signed. So in this scenario, we can have a bad actor who has the same access to that same server with that to use that private key to sign whatever the heck they want. So this obviously poses as a significant security threat. So the bad actor can, tamper with the code, mess with the software, and then leading to security vulnerabilities, data breaches, and ultimately erosion of the users using it at the end. So that's why code signing alone isn't enough. So that's why organizations should have this end-to-end solution that has code signing in place that monitors who can use it and for what. So let's talk about how to exactly design such a system. So there are 5 components here that we have come up with to show you what goes into a robust code signing system. So the very first and foremost one is a private key protection. You want to keep that private key private because once somebody gets a hold of this, they can sign whatever it is that they want to sign and make it look like it's from you. So there's ways to protect your private keys, such as vault, hardware security modules, etc. So we can use those tools as well as creating backups of these tools. Usage control. So we obviously want to make sure that only certain people, certain teams are using the key for their products. So implementing access controls is also important to the overall system. Signing quality. So at the end of the day, we need to have some, we need to define some policies to make sure that only authorized software or approved software can lead the door. So making sure that only production ready applications are signed is important to the system as well. Logging and monitoring. So implementing logging can help us troubleshoot whenever something goes wrong, can help us detect any anomalous events, and it can also help us determine who is using it for what, and this is obviously important for monitoring and determining if there's compromise in our systems. And the last one that's pretty important for code signing systems is integration with development workflows. So we want to make it easy for developers to use. We wanted to make it accessible for developers to use because at the end of the day, if we're asking a developer to follow 5, 6, 7 steps to secure their assets, they're not going to want to do it. So an easy way to do it is to have like an easy solution where they can simply provide their file and it spits out a file for signatures with it. So I'd just like to highlight some best practices in code signing in general. So again, the key management. Key management is the #1 best practice here that we have noted. So storing that in a secure location, such as a hardware security module, as well as having backups and recovery plans. We want to balance the security and usability, right? Like I mentioned before, we want to make sure that developers are actually can easily integrate this with their pipelines. They don't have to follow 5, 6, 7 different steps in order to secure their assets. We want to make sure that everything is up to date in terms of our certificates, and we want to also make sure that there are no anomalous events going on within the system overall. Another key item is security awareness, sort of just, training sessions, ensuring that everybody in the company are aware of code signing in general and how not code signing is a security threat. And yeah, just, with that being said, regular reviews and with the dev teams and users are great, just so that we can continue systems.
Okay, awesome. I know we went really fast, but we'll be out at lunch, so you can ask us some questions there. We'll take questions at the end. But some key takeaways, if you didn't listen to anything that we said, here's the one slider of everything you need to know. Ask yourself your questions in your day-to-day work. Are your keys stored securely? Are you able to control who can use and sign with each of those keys? Can you control what can be signed with each of those keys? And can you provide a history of all operations performed by each of those keys? The bottom line is, if you answered no to any of the questions on the screen, we highly recommend implementing a code signing solution, and we're happy to talk through that with you as well at the end. Here's a slide of how you can get in touch with us. So these are both our LinkedIns. And we're happy to chat with you all about any questions that you may have about code signing, about cybersecurity in general, and more. So thank you all so much for your time, and we're happy to take any questions. Okay, good. Oh, just kidding. We have some questions. All right, yes.
I'm just curious if you know of anybody in the space of code signing for running software, code signing in general. It's not,
Retweet.
but you know, if I want to say start generating files, maybe at that point you could do that. It's like a balance.
I think that's a really good question. We're not familiar with any like systems that are available to like the public. But within like our experience, we've built something internally, so we're happy to talk through at a high level, like what that looks like with you afterwards as well. So, yeah. I don't know if that answered the question. Okay, great. I think there's another question, maybe. Yes.
Yeah, we should talk about whether third party is necessary in this process as a verifier or the getting party and the receiving party, as a developer and the.
Exactly. So it all depends on the product that you're going to release, right? So if you're releasing a Windows executable, for example, these are signed all with a certificate that has been signed by a certificate authority. So there's a lot of certificate authorities out there, Google, Amazon, all that. So these are all need to be signed by such authority. And then for the example that we highlighted back then when we were installing the Steam application, what happens in the background is like when you install that, the Windows operating system is going to detect whatever certificates inside of it and then do some verification in the back end. So it depends on the product. So that's all I can say.
What's the value of something that signing has already been like if you download you can see the all this
So are you saying what is the benefit of the system in general? Because you can see the hashes, everything. Well, you can verify that you can see the metadata of the signatures, right? You can see who the publisher is and other stuff like that. We want to make sure that everything hasn't been already tampered with, and that's what we are able to achieve with verifying signatures.
that's not good. Almost
So in our experience, like with this solution, we're looking at how do we publish software like outside of our organization into like the real world. And so like, yes, you're right, when you download like an YouTube image, it already is like digitally signed. But this is more so for like enterprises or organizations who are releasing software themselves that also need to be digitally signed. And so like an example might be maybe you have a startup where you have like some sort of executable. And so that's not already digitally signed. So this is a process that you can implement inside your organization. So that way, when you do have a customer facing product or capability, that you still have that user trust similar to what the example that you're saying. Yeah. What was it? Can you repeat the question, Richard? Sorry.
So you downloaded if you step back to the source that you downloaded.
So there's ways for us to do that in particular when we're releasing software, for example, right? So what we can do is we have what we call certificate chains. So a certificate chain will have levels 1 to whatever. And then what we have then at the very top is a group level certificate. So when we run this sort of software through some whatever verifier that you have, what you will need to then do is you need to verify that that root certificate is still active, and we can do that using a protocol called OCSP. And then that is how we can verify that everything is in chain up from the very bottom to the very top. Yeah.
Okay, awesome. We'll be in the lunchroom as well, so you can come find us with more questions. Thank you all so much.